think it's just like
Bring down the 3. 3x squared plus 2 squared times 3x squared plus 2 is 6x. And then just multiply those two together.
18x, and then you leave those.
Chris is gonna hear you goddamn murmuring in that goddamn video.
Bro, you were literally on traffic.
Now, this one, there's an easier way to do it and a longer way to do it. A couple of you that did this actually did it the longer way. And what you did is you changed 2x plus 5 to the half power, which I like. And so you could do that. You could change g of x equals 2x plus 5 to the half power, and then bring the half down. I'm not actually going to do that because we memorized on purpose the derivative square root of x. What's the derivative square root of x?
1 over
2
So if you're not sure like how to apply chain rule, you can always just do it with the box or the sum shit. Y equals square root of some shit. So what would y prime be? It would be 1 over 2 square root of, just pretend the sum shit is an x, sum shit, and then at the end, always just do the derivative of the shit. Right, because it's not x, it's the shit. Now, technically, were we always doing that? We were, remember up there? Technically, we were always doing 1 over 2 rad x, but then just times dx dx, because it's just an x inside. What's dx dx? Just 1. Here, because it's something new, I have to do times the derivative of that other. So in this case, what's my box? 2x plus 5. So here, g prime of x is going to be 1 over 2 square root of the box, 2x plus 5, times, what's the derivative of 2x plus 5? 2. What happens to those 2's? Cancel out. So I just get 1 over square root of 2x plus 5. Give me so far how we're feeling. Thumbs up. So, not great. These two a little bit trickier, but not too bad. They're very similar. What do we think? What idea do we have for this? We always, when we had in polynomials, what do we want to do? Did we want to leave it in radical form or change it?
Can you just change it by like x2 over 3?
X2 over 3, perfect. But now instead of x plus 2 to the 2 over 3. Right? The inside, remember the rule is whenever I have a square root, like, you know, if you call this a, and then like x to the, say, b, the rule is that the b one goes on top, the inside one goes on top, the outside one goes on bottom. That's the rule. You have to put that in your notes unless you forget. So if I rewrote this, h of x, notice, did I take the derivative or rewrite it?
Rewrite
it.
Good. X plus 2 to the 2/3 power. That's the key here. Once you do that, it's really easy. Okay, what would be my box?
X plus 2.
X plus 2. And then, so h prime of x would be, and this is how I want you to start thinking of it. Just take the outside. What's the outside?
2/3.
2/3. What would be x to the 2/3 power? What would I do? I'd bring the 2/3 down, and then I'd subtract by 1. But just this time, leave that box alone. Now I'm going to just kind of cross it out, so I remember I already did that. What's 2/3 minus 1? Negative 1/3. Perfect. And then times, don't ever forget this part, times the derivative of the box. What's the derivative of the box here, though?
1.
Just 1. And sometimes chain rule works out that way. If it's just like x plus 2 or x plus 3, like if the coefficient is 1, the chain rule doesn't really do anything. That's okay. Just still do it so you make sure that you're getting it right. And you can just box that answer. Honestly, I'm fine with you boxing that answer. Could I rewrite it back if I really wanted to?
Yeah.
Where would the x plus 2 go? Into the denominator, and then it would turn positive. And I'm going to skip a step. What's to the 1/3 power? Becomes cube root of x plus 2. So that would be written, you know, same thing, but just written back into radical form. This one scares some people because of the 5 in front. Don't worry, what's the derivative of 5x? Just 5. What's the derivative of 5x squared? 10x. But how did I get that? 5 times derivative of x squared is 2x. So the 5 is just a coefficient. It's just going to hang out. It's the exact same problem as the one before. except just different inside.